Hi, welcome. This is another video which I'm going to do two trig proofs going over the different aspects of how you actually look at these particular trig proofs, how you can actually go down the wrong path, and how you realize that and start coming back and start going down other paths. The first trig proof that I'm going to go through is question 3 of the sheet of trig proofs, and that is sin A plus cos A over sin A minus cos A equals 1 plus 2 cos A sin A over 1 minus 2 cos squared A. Now, a couple of things that you can do when you start looking at that is immediately this side over here, when I look at this I go 1 minus 2 cos squared A, I can see straight away from the formula sheet that that's just minus cos 2A, that's just a double angle formula. And on the top line there, whenever it says 2 cos A sin A or 2 sin A cos A, same thing, that's just sin 2A. So straight away my first instinct would have been to simplify it like I've written there, right hand side equals 1 plus sin 2A over minus cos 2A. However, when I look at the left hand side, that doesn't seem to have helped me at all. I've now got things in terms of 2A, whereas on the left hand side there I've got things only in terms of A. So yes, it can be simplified in that way, but it's not actually taking you anywhere. So the next thing that you could have done is, realizing you want a plus 1 or a minus, or 1 minus on the other side, is dive straight into actually just dividing both sides through by sine. If you divide the top line by sine, you get a 1. That one, the cos A by sine, you get a cot A. This one by sine, you get a 1. And this one by sine, you get a cot A. Now I've got 1 plus cot A over 1 minus cot A. Again, yes, I've got the 1 pluses and the 1 minuses, but I don't have what I've got on the other side there. And I cannot make that 2 cos A sin A is never going to be cot A. So again, that's going down the wrong path. So several different ways to be able to do this. We could start with either the right hand side or the left hand side. In the answer sheet there I've started with the left hand side. This way I'll actually start with the right hand side. When I'm looking at the left hand side there, I've got a sin A minus a cos A. So I'm wondering if I can get something with a sine minus a cos. When I look at the formula sheet, 1 minus 2 cos squared A is the same as sine squared A minus cos squared A. Well, that's looking very similar to what I've actually got on the left hand side there. Because I know that sine squared A minus cos squared A can factorize into sin A plus cos A over sin A minus cos A. So I've got the bit on the bottom that I'm looking for. What I'm really hoping for now is I'm going to get a sin A plus cos A all squared on the top. If I do, it can cancel out, my proof's almost finished. So what I really want on the top line there, if I go over to here, what I really want on the top line is I want that top line there to be the same as sin A plus cos A all squared. If that's on the top line, then I would just have sin A plus cos A on the bottom. I could cancel out one of them and I've still got sin A minus cos A, and my proof would be done. However, that's not what I've got up there, so I've got to actually think about, okay, what sin A plus cos A, if I actually expanded that, what would it look like? So I've rubbed that out because it's not what I've got. So let me think about the other way. If I've actually got sin A plus cos A all squared, what does it actually look like? That would actually look like sine squared A plus 2 sin A cos A plus cos squared A. Well, I've actually got a 2 cos sin A and I've got a 2 sin A cos A, so those two things are the same. But I need a sine squared plus a cos squared. What I've got up there is a 1. Well, actually sine squared plus cos squared is 1. So what I could do is I could rewrite that. I have actually got that on the top line, which is exactly what I'm hoping. Otherwise the proof isn't going to work. So what I've got up there is I've got a 1. So if I rewrite that as sine squared A plus, and I'll just change it, 2 cos A sin A plus cos squared A. Remember, the sine squared and the cos squared is just the 1. This is still all over sin A plus cos A into sin A minus cos A And remember, the reason why I did that is because that's the bottom line that I'm wanting. Right, if I factorize the top line there, I've actually got sine A plus cos A all squared all over sine A plus cos A, and I've got a sine A minus a cos A on the bottom line as well. Right, that then what I can then do is cancel out one of those, and I'm left with sine A plus cos A over sine A minus cos A, which equals the left hand side. So go back, how did I actually see that? I'm always looking for what I want on the other side. So when I started up this one here, I went, right, can I get a cos squared on this side? The only way I could get cos squareds on this side, like as you saw in the formula sheet, was I had to have multiplied something on the top and the bottom, because obviously something's simplified out because there's less terms on the side over here. I've got cos squareds and cos sines, I've only got single ones, so something is cancelled out, so I'd have to multiply by something. So I started with the right hand side, and I know that I want a sine minus a cos, so I look at that part there and I go, right, is there anywhere in the formula sheet that's going to give me a sine minus a cos? And there was. I've got a sine squared minus a cos squared, which is, I know that that then can factorize into sine plus cos, sine minus cos. So then I go, right, great, I've got the bottom line there, I just need the top line. It would be wonderful if the top line was sine A plus cos A all squared. Actually, it has to be, so they will cancel out. How does it do that? Well, then what we do is we know that that there, to make that, has to be sine squared plus cos squared. And we know that sine squared plus cos squared equals 1. Therefore, you've got this here, sine A plus cos A all squared, which comes up from factorizing up the top there. They then cancel, and you're left with sine A plus cos A over sine A minus cos A. A lot of this was algebra. A lot of this was the fact that x plus y equals x squared plus 2x y plus y squared. You had to know how to expand x plus y all squared, and also the fact that x minus of x squared minus y squared is x plus y, x minus y. Those were the two algebraic things that they expected you to recognize in this proof. Okay, go over it just quickly to another proof over here. I've got a sine 2a and a 1 plus cos 2a, and I've got a tan a on the other side. That's already simplified. I'd actually have to do a bit of work to actually make that into several different terms. So you start with the one that has more terms. There's more in the other side. So this time I'm going to start with the left hand side. These are only got a's, these have got two a's. So I need to get these all in terms of a. So I'm going to use the two double angle formulas. At the top line there, that's 2 sine A cos A. And on the bottom is 1 plus cos 2A. If I go 1 plus cos 2A, that's just 2 cos squared A, which is just cos A cos A. So my 2's will then cancel, and I'm left with sine A over cos A, because my cos A over cos squared A just leaves me a cos A on the bottom. This is tan A, which is the right hand side. Again, it's all about always looking at where you're going, at what side that you're actually looking at, and you always start with the side that has more information, and you're always looking at how to get to the other side. Go back to that original proof. There are lots of simplifications you can do, but unless it's actually helping you get where you're trying to go in the particular proof that you want, it's not actually taking you anywhere. So you're always trying to look from where you are heading. Thank you.